Hello, hello, hello. So we have seen all the modules, functions, crates, I guess cargo, or we have to see the cargo. So let's see. Today is our, part 10. So we have seen crates, we have seen modules, we have seen functions. As for what they sort of mean in one liner in Rust, I have asked this GPT to create that. So crate is the smallest compilation unit in Rust producing a binary or a library. We know that because we produced both. Like we produced library using these commands. Where is this? Yeah, rust c and then library ni executed, and we also created sort of a binary. We know how to create a binary. So create is used to create a binary or a library. We have seen all the libraries file over here. As for just rust c and some file.rs, that will create a binary. So we know what the crate is. So the next thing it is saying that module or mod. It is a namespace that organizes code into hierarchical unit within the crate. So there is a crate. Inside that we need a hierarchy of the code. So module does that. And function is, we all know, is a reusable block of executable code that performs a specific task and may return a value whenever you call it. So you have to call function. Remember that. And so cargo, well, it is the official building system and package manager used to compile the code. It manages dependencies, run projects, and tests and all the other things. So yeah, there's a one-liner. Cargo builds and manages. Crate is sort of the whole project. The module is the folder or namespace inside the project. Like if I created something like, let's see, tree of okay, 11. Yeah. So we created 11, let's say, very small program. We used it to create a library. Now there is, use.rs, rary.rs. So use will be module one, rary will be module two. Like we can just use these just directly by the name, but we have to import it from crate, uh, sort of, use crate, then colon colon use, something like that. We know that. We know function, how it works. We can make function public, but by default it is not public, it is private. So by default any function is private. To make it public, to be seen from anywhere in the crate, you need to make it private. Sorry, you need to make it public. All right, this was a small sort of summary of what we did in all these days, from function to modules, from to crates. Now this is our day for cargo. This is a cargo. So what is cargo? Cargo is the sort of official Rust package manager tool, and it has a lot of useful features to improve code quality and developer velocity. Velocity, speed, but in a direction. So velocity. Now these includes dependency management and integration with crates.io, which is the official Rust package registry. Awareness of unit test. Yeah, we did it. Awareness of benchmark. We also made some benchmarks, if we remember that. Not in this live, uh, in sort of our day 2 or day 3. That's our 100-day challenge. We made both of them, a unit test and a benchmark. So this chapter will go through some of the quick basics, but you can find the comprehensive docs in the cargo book. So this is our next book. I don't think we'll go through it because you know we shouldn't, because Rust books are very well documented. So we'll just start preparing for some project, and then if we find ourselves into some ditch, we'll just search about it and we'll get the cargo book or other books. There are a lot of books for Rust, and that's what I like about this. Yes, without books, you don't get to learn things very officially. You can try and hit an error, something like that, but you can never learn something properly. Now, dependencies. So, most programs have dependencies on some libraries. So, if you ever manage dependencies by hand, you know how much of a pain this can be. Luckily, the Rust ecosystems come standard with Cargo. Cargo can manage dependencies for a project. Now, yes, the thing it's saying is like if you are if your project is based on some dependencies, that dependency, even if it sort of updated or something like that, or it degraded or might have been compromised, then you have to face that consequence. Sometimes you have to manage those dependencies. Mm, So it's saying that Cargo can do that for us. Now to create a new Rust project, create new foo. We'll not create foo. We'll create uh, well a 12 if we want to. But right now, do we need? I don't think we need a new project right now. There's 10, 11. But to use Cargo, we'll create it. All right. So to create a new Rust project, we'll create foo, and a library we'll first of all flag it as a library, and then we'll name it as bar. So foo and bar are two things. So we see a tree where bar is cargo.toml as always, src, then lib.rs, not main.rs but lib.rs because it's library. uh, for the rest of the chap for rest of this chapter, let's assume we are making a binary rather than a library, but all of the concepts are the same. After the above command, you should see a file hierarchy like this. Yeah, all right. Now main.rs is the root source. Main.rs is the root source for your new project called foo, and nothing new there. We all know that. The cargo.toml is a config file for cargo of this project. If you look inside it, you should see something like this. Yes, absolutely. Now the name fields under the package, which is foo, determines the name of project. This is used by crates.io. If you publish the crate more later, it is also the name of the output binary when you compile. Yeah, yeah. So it's like uh, if I compile, 5.rs, it will give me 5. So think about if I compile something from a whole project that is foo, and if I try compiling it, it'll say we are compiling foo, and it will give me a executable foo. That's what happens. So if you publish the crate more later, which is we'll read it later, it is also the same name of the output binary when you compile it. All right. So the version field is created. Sorry, the version field is create version a number using semantic versioning. So this is a version, and it is the version for create using semantic versioning. So let's see what the semantic versioning is. If it's long, we'll not see that. But I see a summary. So given a version number which is major.minor.patch. All right, major increase, well, over here, minor somewhere here, if we just patched it over here. Increments the major version when you make incompatible API change. All right, minor version when you add functionality in backward compatible manner. And in patch version, when you make backward compatible bugs fixes, additional labels for pre-release and build metadata are available as extension to the major minor patch format. Now this is good. I get an idea where that this is not a random number. This is if we do a major update, we increase its count, the first ones. If this is just a minor update like backwards compatibility and all that, we increase this count. If we fix the bug of the functions or all that like patches, we increase its count. Now authors is Mark. Well, we didn't define any author, so I don't know what we'll see. Let's first of all see some already defined cargo.toml if we can. Uh, Not here. Cargo. We did not use cargo to create them. So how about we first of all create it and then we'll see it. So we'll create 12 and get into 12. Sorry. Then what we'll do is say cargo new. How about library? So it's just a flag. We can also say binary. So there are certain flags. See, we have certain flags, which is binary, color, addition, frozen, help, binary, lock, name, offline, void, registry, VCS, verbose, and all that. We'll create a library for now. It'll give us a lib.rs instead of binary and main.rs. So library, we name it as foo. Let's go with the same name. Now, if we see, we have a foo directory. Inside that, if we go, we see something like cargo.toml, and we want to see that. All right. So we see name of this project, which is foo. We see version, yeah, exactly like this. We see edition, that is 2024, but this is 2026. So why? Why do I see like, am I 2 years younger? Why 2024? I don't know. And for reference, let's see. Sorry, the tree of this project. Yeah, we have src. Inside that, we have lib.rs, cargo.toml, and we are fine. We're good to go. Now, as for the author, we don't see it because, well, we might have not defined it. So, author field is a list of authors used when publishing the crate. Oh, so I guess if I use some other authors, I might get to see the list of authors. Like if I use some other packages, you might see some author's name inside those packages. Dependencies, this section, we have zero dependencies. Yeah, over here we have zero dependencies. So this dependency sections lets you add dependencies for your project. Well, I have a bit of idea. Yeah, exactly like this. So clap, rant, bar. If I created bar, let's create bar too. All right. No, from here only. Cargo new and let's create bar. Just we have a foo, we have a bar. And now if I go into, if we want to, we can go into foo and inside that we can go into cargo. As for dependencies, we can add a new line saying we have dependencies of, bar. Interesting. How? Oh shit. It's like bar and then path. All right. We'll do that. We'll do that. And path is exactly like this. So let's say it is a path. Here we'll say this is bar is equals to path and then in a curly brackets so one comma. Is it good? Path equals to also. So we have to include path equals to, and this should be removed from here. Is there any problem with our dependencies? I don't think so. But now we know how we can add dependencies. So this is our local path file. If you want, we can add a different path or different dependencies like rand and clap. Well, we'll try that. Before doing all these, let's first of all, see what sort of cargo.toml has been created for bar. It's the same. I don't know why the addition is so late. Now, if I, add something from online repo, will that be downloaded automatically or something will happen? I have no idea. As for claps, well, crates.io, so I think it is offline. Let's see. Will I have to download something or not? This is where we started. Let's paste it. And then let's go back. And if we try cargo run what? Who? Or cargo build? Sorry. First of all, go into foo. Now we'll say that. Cargo run. A target bin must be available. Don't we have that in SRC? We have something, but let's see what it is. It is like, all right. So we don't have a binary saying, hello.rs. So we'll create it. We'll go back, go more back. Over here, we see some of the 5.rs. So let's see what the 5.rs is. Sorry. 5.rs. So it's a print statement like normal. So we'll just copy this 5.rs inside. This is day 12 foo in SRC over here. Now, if we go back to 12th foo and SRC, we must see 5.rs and all that. So now if I say cargo run, what will happen? A bin target must be available. Cargo run. So I think we have created a library using that library sort of. How about cargo build? So updating crates.io. Now, as for this repository that was rand, we have to fetch it. So now it's first of all fetching it. All right. So now this is interesting. As for the tree, what happens to it and all that, we'll see it. So let's move on till it's downloading. So we see something like cargo is more than a dependency manager. All of the available configuration options are listed in the format specification of cargo.toml. Let's see what that format specification is. So this is format specification, and these are all the features that we can use sort of with cargo. Nice. But for now, which section is this? Like, where is it being taught? Oh, so this is a different book. Yeah, the cargo book, not Rust by example. So we now know that there are multiple things that a dependency manager or cargo can do. There are multiple configuration options that are listed for cargo.toml in format specification. Now to build our project, we can execute cargo build that we did. As for cargo run, it will not run because there is no binary for that and all that. Anywhere in the project directory, including subdirectories. So in any subdirectories, we can say, cargo build and it will start building. Did it build? It's still fetching. Damn. I hope my internet is good because I'm live streaming, but yeah, it is good. But downloading it is taking some time. 10 complete, 1 pending. I don't know why. So to build our project, we can execute cargo build anywhere in the project directory, including the subdirectories. We can also do something like cargo run to build and run it, but we tried build. Build well went a little bit smoothly. As for run, we were seeing some sort of errors. Why? I don't know, because a bin target must be available for cargo run. 24 complete, 7 pending. Notice that these commands will resolve all dependencies. So download crate if needed and build everything including your crate. Note that if you rebuild what it has not already built, similar to make, voila, that's all there to it. Well, there is more confusion now. We know crates, we know cargo, but it says something like download crate if needed and build everything. Where should we download that crate? Is this also sort of crate? And this is also crate. This is also a crate. So everything in these dependencies are crate in itself. But we are importing them to use these crates or their codes, and including your crates like bar, I guess. Note that it only rebuilds what it has not already built, similar to make. Well, I've never had an opportunity to, you know, run a make. So, voila, that's all there to it. There is to it. Now, convention looks something like this. This is a subtopic. Convention, then test, then build script. Well, I'll want to sort of see this happening, something well impressive. Convention. So in the previous chapters, we saw the following directory hierarchy, something like this. For foo, there was cargo.toml, then there was main.rs. Well, we did not, because we used a lib sort of uh, library flag. So it is library now. So we don't see main.rs, we see lib.rs. And it says, suppose that we want to have two binaries in the same project, though. What then? So it turns out that cargo supports this. The default binary name is main, as we saw before, but you can add an additional binaries by placing them in bin directory. So in benchmarking, if we remember correctly, we did something like this. We created a directory bin in the src, and then we created all these benchmarking binaries inside that. Just one, but still, we created a binary. It says to tell cargo to only compile or run this binary, we pass, yeah, something like a flag called bin. So cargo, the bin, and my other bin, which is this. So it sort of only compiles and run this binary instead of running, main binary or something like that. Flag where the my other bin is the name of the binary we want to work with. Exactly. In addition to extra binaries, Cargo supports more features such as benchmark tests and examples. Oh, oh. Now inside binary we have executable, another executable, multi-file executable, which is main.rs and some module.rs. Then we have benches or sort of benchmarks. Uh, all right, we have then examples, we have some tests. Oh yeah, this is a very extensive sort of demo tree. So in the next chapter, we will look more closely at tests. Let's go. So in SRC, we have lib.rs, we have main.rs. Well, ah, it finished, sort of. So it says foo, ignore the dependency bar, which is missing a library target. Ah, it is because we have not compiled bar as a library, which we have to do. We know how to compile it in a binary. For now, let's ignore it because there's more to it. Uh, let's first of all create a tree. We see lib.rs and 5.rs. So instead of 5.rs, we'll say move it from 5.rs to main.rs. How about that? CD. Now if I say give me a tree, oh, oh, so there's a target because, well, it now has some dependencies. So we see depths or dependencies. Now we see multiple things. And we see lib foo libraries. So yeah, interesting. So if I say cargo run, will it run? Ah, so it is running and it is finding some errors in our main.rs program. No need to worry about that for now, just for now. So our main.rs was running. We have a lib.rs that is there. And as for tests, which is my test.rs, my other test.rs, we'll create it sometimes. So to create it, we don't have to, make directory test and all that. We can just directly say cargo test and it'll create it. Well, now that is interesting. So each file in test is separate. First of all, let's make that main.rs very simple in SRC. First of all, SRC and main.rs. Instead of, saying you have a vector, we are printing or trying to print a vector stack. And then we are creating a closure which moves the haystack dot contains dot needle and it preserves that in a contain. We can try running contain and there shouldn't be much of error. As for this, we have moved it to contain and we are only trying to print it. Yeah, so it says there are element. Why is this creating a issue? So let's first of all go back. Shit. Uh, and remove this 5.rs and try running rust c rust c 5.rs. We get the same errors like contain is something like needle. We have to say something like needle and move is preserving that needle in a closure and the contain argument is ampersand integer is missing. So we'll see to it. Vim 5.rs is he contain needle haystack dot contains, which is a vector. Yeah. So after moving, we were trying to not print anything out of it. Now, if I try to run it, yeah, it first of all gives us the haystack and all that. So now let's go back to our project, day 12, foo. Inside that, we have a main. So vim src inside main. Let's sort of comment this out because it has not, contained not whatever. and we are trying to print the whole lamp contain without passing any sort of integers or sort of index we want it to print. Contains does what? It moves sort of the needle, which is I32. For needle, we find haystack.contain, and then we try to find that needle. If it is there, it returns true. If it is not there, it returns false. I guess this is for one. Now, if I say cargo and run, it should run. See, same. If I say it's something like 5, will it run? Like instead of passing 1, how about I say something like replace it with 5? What sort of errors should we see? We see false, not any error. So we know 5 is not there. We have 1, 2, 3, not 4, not 5, not anything. So it's a false. So now we know our program is running quite fantastically, and it works. Sort of. So now I want to test something like cargo test, but before doing that, let's read what is there. So in each file and test is separate integration test. Like what is integration test first of all? And then it says a test that is meant to test your library as if it were being called from a dependent crate. So testing chapter, which is there, this is our testing chapter. Where is it? In 21. So we'll see this test and all that. So no need to go through it right now. All right. So we'll see this testing chapter somewhere. As for integration tests, so in Rust, integration tests are entirely external to your library. They use your library in the same way any other code would, which means they can only call small functions that are part of the library's public APIs. And the purpose is to test whether many parts of your library work together correctly. So units of code that works correctly on their own could have problem when integrated. So test coverage of the integrated code is very important as well. To create integration test, you first need a test directory. All right. So inside test directory, we try to test our sort of integrations or any sort of libraries that we imported. That's what I understood from it. So test that is meant to test your libraries as if it were being called from a dependent crate. Now testing chapter elaborates on the three different testing style, which is unit, docs, and integration. Cargo naturally provides an easy way to run all your tests by just running cargo test. You should see an output something like this. Uh, you can also test whose name the matches a pattern. First of all, just try running cargo test. Cargo over here, let's say test. Oh, it's not car, it's cargo. Cargo, cargo test. So we have a test running on tests. It works. Then we have unit test src main.rs. It works. We are doc testing for foo. It works. So test result is 0 passed, 0 failed, 0 ignored, 0 measured. Is there's nothing to test, I guess. But it's trying to test our dependencies. Well, interesting. Really interesting. So the next one is cargo test, which is test foo. And it says you can also run test whose name matches a pattern. So we can say cargo test and test foo, but we don't have a test foo. So can we say test par? Can we say that? and we'll be getting errors. Cargo, and we want to test the bar. Should we go, sort of end it? Ah, it runs. There's no error in test bar also. Ah, there is a warning, but it says ignoring invalid dependency bar, which is missing a library target. So bar should be library, not the foo. But we have created foo as a library, so I guess. And one word of caution is that cargo may run multiple tests concurrently. So make sure that they don't race with each other. One example of this concurrency causing issue is if two test outputs to a file, such as below. So there is a configuring a test. We are configuring a test. We are creating a mod test, which sort of uses the or sort of imports the necessary or needed modules, which is open option and then write. So we are trying to open something and then write something to it. Now this test does what? It is a function test file. So first of all, it creates a mutable file variable, and we open option a new sort of file. And we append true to it. We create it. We open something like ferris.txt, and if there is sort of error, we expect it to say something like failed to open ferris.txt, which is good. Now print Ferris 5 times. So now we want to print Ferris 5 times inside that. So for, while equals so sort of range of 0 to 5, and we don't want to, use this count variable anywhere. We are just going with it, with the flow. Oh, so for 5 times, what we are doing is we are saying file.write all, which I guess is a library function. We say something like Ferris, and then we give it a backslash n, which is new line, and we want to write as a bytes. Why bytes? Because I guess it is a text file, so yeah, bytes. And if it fails, we expect it to say something like could not write to ferris.txt. Now this is a very extensive sort of, because I don't remember sort of creating something or playing with some text files in Rust. But we now have an idea how to do that thanks to this test. Now there's another test going on, I guess simultaneously, on the same ferris.txt. And it is also trying to run 5 times, sort of, try to write 5 times, which is coro slash n as bytes. So we are doing both of them. I guess this might happen side by side, but it shouldn't, because if Rust follows the line method, like first go through this line, then the next, then the next, then the next, like C, then this shouldn't have been problem. But I guess it is, because they are both racing against the same file, doing the same thing, even if it's written below the first test. Although the intent is to get the following, which is like Ferris, Ferris, Ferris 5 times, and the Koro, Koro, Koro another 5 times, you actually get gets put into ferris.txt is this. You get something like Koro Ferris, Koro Ferris, Koro Ferris, Koro Ferris, and all that for 10 times. All right. Should we do this? I don't think so. Let it run. Let it be. So we have a test files. Let's copy this. Let's copy this. I think we have to create something like, let's try running it. Will it run over here? I hope not. So it ran. So it sort of was a test. So let's try running it in our own sort of local machine. Let's see what we have. We have a src, we have a target. Let's mkdir something like test, and inside that test we have a test file. Inside that we have this code that we have copy pasted, but we don't have something called ferris.txt. So I don't know, do we have to create that ferris.txt or will it get automatically created if we don't have that? Let's see. Let us see. And what I should do is, should I step back? Nah, I can just directly say, cargo test files and ferris.txt if it exists. Or the other thing we can expect is a damn error. Let's see. So it's saying bar, all right, bar, no such. Ferris.txt, no such file or directory. All right. How do you? So this test did not create anything like ferris.txt after all. What did I even expect? Will run automatically and it's not a program, I guess. So that's expected. How about we create ferris.txt? Ferris.txt, I think spelling is correct. Now we have a ferris.txt. Now let's try running our test. And we have nothing in ferris.txt. We sort of don't know how to write a file, but it was trying to sort of, tell us what could happen, what could have happened. Let's do something like move this from test to something like src. Now let's see the tree. Yeah, there is nothing in test. In src there is something lib.rs and then test file. Now if I try to just cargo run, will I see something in ferris.txt? Nah, still nothing. I want to learn how to write files and all that. Where will I learn that? Well, it gives us an expected idea. We still don't know, and this is a test, so yeah. And I have another doubt. Like, we have defined this function called test files, and we have defined it as test file also. Now, we are not calling these functions. Do we need to call it, or will it work by itself? And another thing that I want to test is if I just remove the target, what will happen? Target, and let's also remove tests. So we have nothing. And now if I try to cargo build it, it will start installing or something like that, because there were libraries. So yeah, it is not installing, but it is from there. So like Python, in Python, what happens if you pip install any sort of libraries, it gets sort of installed in your virtual environment. In what sort of environment does these libraries get stored, and can we remove them? So I don't have any idea, any clue whatsoever. We'll just pass it for now. We'll go to the next. We'll see something. This is our last topic, which is build scripts. Then we are free to go. As for not having much of idea because we don't have experience yet. We are still learning, so it's normal. Now build script. So sometimes a normal build from cargo is not enough. So we have to create a build script in a package, something like that. So sometimes a normal build from cargo is not enough. Perhaps your crate needs some prerequisite before cargo will successfully compile. Things like code generation or native code that needs to be compiled. To solve this problem, we have built script that cargo can run. Now to add build script to a package, it can either be specified in cargo toml as follows, something like this. Otherwise, cargo will look for sort of build.rs in a file project directory by default. And how to use build script? The build script is simply another Rust file that will be compiled and invoked prior to compiling anything else in the package. Hence, it can be used to fulfill prerequisite of your crate. Now, Cargo provides the script via with input via environment variable, which is specified here. You'll see them that can be used. Now, the script provides output via standard output. All lines printed are written to something like target, debug, build, and the package, then their output directory. Further lines prefixed with cargo will be interpreted by cargo directly and hence can be used to define the parameter for packages compilation. Now, for further specification and examples, you have to read cargo specifications. We'll go through that too, but for now, environment variable. So standard environment let out directory or output directory be something like environment directory and unwrap for any sort of errors. All right, we don't understand most of these cargo CFG features, Unix, Windows, target, but yeah, bit of idea. So I think it's workable. As for build scripts, what is there? So in build script, we run src hello.c. Oh. So if a sort of code depends on some other outputs, like let's say hello, which is let's say a binary for now, and we are using that binary in our Rust code. So first of all, we need to compile the code of hello.c to get a hello. So we do that first of all, and then we use that. So this function main is first of all printing that cargo rerun if changed, then src hello.c tells the cargo that if given file changes to rerun the build script. But this is just a print statement. So how is it telling it? I don't know. Now I guess we have to define this somewhere earlier in our build script. And CC is there. I don't know what it does. Cargo changes or something like that. Build is there, then a new. All right. Inside that, we have a dot file, which is giving it a path of the file, which is src hello.c. Inside that, we say compile it in a output called hello. Some example use cases of build scripts are building a bundle C library, finding a C library on host system, generating a Rust module from specification, performing any platform specific configuration needed for the crate. So if cargo can now sort of, I have an idea how it runs, sort of C program. Now, if I try to, import some libraries which were written in C, written for any other sort of language, but written in C, will it still compile? Like something like NumPy. NumPy is written for Python. So can we use it in Rust? So this is our last question, and we'll end this. But for now, let's see. So if we want to use the NumPy, that is a library for for Python, but written in C. If we want to use the NumPy in our Rust code, can we build it or use it? Yes, but not directly the way Python does. Rust has few different ways to interact with NumPy. So call NumPy through Python, most common. Libraries like PyO3, Rust NumPy, NumPy. What is this Rust NumPy? So we see a concept code which is use PyO3 and we say prelude and then we say everything from there we want to use. Inside main, we sort of run something and we get a result of py result. And then we say Python with GIL, again a closure. And inside that we are saying let np is equals to py dot import numpy, array is equals to np dot call method, which is array. And we say print and then we okay. Now Rust is using the Python interpreter, which is using NumPy, result back to the Rust. Now this will get, I guess, slow, very slow. So you want NumPy ecosystem, you can use it like this. You already rely on Python, oh, not that. Use Rust native alternative, which is recommended for pure Rust. Yeah. And I guess it will be faster also. So I don't know. It says use ND array, which is array. And inside this array, we have, yeah, so it's like NumPy, but for Rust. And we are doing the same thing. So we are sort of trying to get a dot product of A and B. That's what it does, I guess. Let's try running it, shall we? How about in main.rs? Where is main.rs? Vim src, inside that main.rs. Now we have printed something we don't want to. Let's open up a line. And how about print this? Automatically get indented. Now we want to run. It says use a unresolved module unlinked create ND array. Oh shit. Sorry. I just closed it. So I guess I'll end the live stream now.